So 2 days ago, 2 days ago, the co-founder and the CEO of Facebook, you know who, right, was in Beijing to give a talk to a group student, and he's supposed to just say a few words in Chinese, then switch to like English. But when he started actually talk in Chinese, and the student actually loved it, and they absolutely going crazy, and he started to use Chinese for entire talk. I thought that was fantastic. So I want to try you guys Chinese skills. So if I switch to Chinese, you know where to get me back. Okay. All right. So my name is Tong Li. I'm a senior software engineer at IBM. I've been working on OpenStack for about 3 years. The reason why I work on monitoring is because previously, before I worked on monitoring, I was working on a project called OpenStack Accelerometer. Okay, that was a project developed to do the metering, to kind of get the billing information to charge the cloud users. When the project gets involved over time, and people started using accelerometer to do monitoring, of course, it wasn't designed to do monitoring very well. So when you start using it to do that, you get all sorts of problems. So about 6 months ago, 3 companies running, you can see it, cloud, got together, figured, we really need something that it's real, can do monitoring for cloud and for many other things. So that's how I got involved into the monitoring business. So before we dive into it, let's see, what actually we do in our human history for monitoring. Long time ago, many years ago, and people start, build this hourglass, right, to actually measure time, monitor time. And people also build lighthouses, right, to help, people to navigate their ships. During the first century, there is this Chinese scientist. His name is called Zhang Heng. Right? He's not only a scientist, but he's also a painter, right? An engineer. He built this little, well, I shouldn't say little. He built this device. It looks like a standing egg, right? This device has got 8 little dragon at a different direction, okay? So you have one on west, one on east, north, south, 40 degrees to west and east. So you have these 8 dragons. Each dragon actually has a little iron ball inside its mouth, right? Then under each dragon, you have one frog, have the mouth wide open. Okay, so this device was used actually to monitor the Earth. Okay, when there's actually earthquake happening somewhere far away, the iron ball from the dragon towards that direction will actually drop to the frog's mouth. So that's how people actually know there's an earthquake. You can imagine, long time ago, first century, people already realized, how important monitoring is, and those things are useful. So, well, I consider that's in the East, right? Chinese people. I'm one of those, by the way. back to the West. I think, according to the Bible, if I remember right, I think this is from the book of Matthew, chapter 2. It says, right before baby Jesus was born, right, there were 3 wise men from the East and knew, actually, the King of Jews will be born, right? But how do they know? How did they know, actually, this will happen? Anybody know? According to the Bible? Stars. Yes, they monitor stars, right? Not only they know the King of Jews will be born, but also they know where to locate him by following the stars, right? In my view, that's some serious monitoring. So that's in the past. Okay, so what is today? Everybody knows this, right? This is a fantastic tool, and it's so simple and it gets used every day, I imagine. This is great. And we know this, right? I don't know if you recognize these things. This actually is a device to monitor the air quality and also the noise level, right? So with a lot of pollutions around the world, these kind of things, kind of useful as well. And security monitors, right? We can find those everywhere. And when a lot of people get onto internet, many times we complain our internet is so slow, so people wanted to know, how exactly our internet is doing. So you have those internet speed monitors, right? And people want to know how your brain actually works, right? There's brain activity monitors. Right? Those are fantastic technologies. Everybody knows that, right? Yeah. How about this? Exactly, ultrasound machine. I heard these things before, but the very first time that machine hooked up with my wife's stomach, I heard my daughter's heartbeat. That was a stunning experience. I thought that was just fantastic. People actually can do that. So we know this, right? We are, I think the mid-season midterm election is right around the corner, right? In a few days. If you are a political junkie, probably you really want to know, what's going on, who's hot, who's not. How actually do you know the temperature of the election, right? So many times you go back to the old-fashioned ways of asking people questions. That's some kind of form of monitoring, right? And you have those flying drones. Right? The other day I was watching TV. I heard on the news that there's local high school. A bunch of students actually built the drones to monitor the high school football game. During a football game, they take a lot of pictures, and because that was a fundraising project, but they had a great success, and also I heard people use those drones. Other than military purposes, do a lot of other stuff like monitoring your water quality. Those drones can fly to many places that it's hard for people to get to, right? All kind of equipment, all kind of devices for monitoring. And this Everybody knows what this is, right? The telescope. This has got to be the masterpiece of human-built monitoring device ever, right? So you can see the monitoring is with us, is in our lives from many, many aspects. And the day I was on the internet, I happened to stumble on this thing. And it says a company actually developed this smart cup, right? The reason why they say this is smart is because this cup actually can distinguish if you drink from the cup or actually you pour water out of cup. So if you drink, it knows. If you pour the water out of it, it knows as well. It's just smart. And it also can actually calculate the amount of water you need according to your body mass or the temperature of that day, and also the activities you take for that day. It can calculate the water you need. And of course, we record how much water you take per day. And, the freaky part of this is that it says this cup actually can remind you when is the time actually you need to drink water. The reason I guess why they did that is because they figured that there was a study that says if you feel thirsty and you want to drink water, actually your body is already 2% dehydrated. Okay, if you don't drink at that time, when time goes on, your body actually needs more water, but you feel less thirsty. You won't drink, right? You can see where this is going. So they create this cup to remind you, kind of let you know, okay, it's time for you to drink, right? It does a lot of other things. After I saw this, I was thinking, this is really weird, right? You're working, the cup start talking to you, drink your water. They say, I don't, right? They say, I didn't follow the instructions. I wonder what the cup will say after 3 times it reminded me. What did it say? Drink your damn water. Okay, so you can see that people can put the monitoring at the extreme, right? There can be many useful things. So in the future, when I think Cisco really want to talk about Internet of Things, right? This is happening. When many, many things get connected onto the Internet, you can imagine a lot of data generated is from monitoring. It's from monitoring, right? No matter is your car connected to internet or your home appliances, right? Your microwave, your air conditioner, right? Those stuff connected to internet, the data gets created. We keep talking about big data all the time. Those data generated, most of it is from monitoring. So monitoring is really, really important. Right? Before I offer the monitoring as service, let's just look at how the monitoring normally is done. I have this little graph here. At the bottom, I have a box called MoniT. Actually, I made up that word just to make this presentation a little bit easier. So in this box, MoniT presents anything that to be monitored. Okay, so it could be a machinery, right? It's a piece of equipment or something man-made, right? Present pretty much anything human created. Then in the middle, I have this little girl on horseback. Right? That pretty much presents humans, animals, insects, whatever, right? Living things. Then the environment, the beautiful vacation, thing, present our environment, nature. So you can imagine many, many things can be actually monitored, right? So I have this box at top. I call it monitor. I use one-eyed camera to present the whole category of the monitors. So when we do monitoring, the very first thing is to actually collect the data, collect the information from the things actually you monitor, right? We will talk about how collector actually works later on. So once you collect the data, most likely you want to save the data either temporarily or permanently somewhere, and you want to analyze the data, right? Eventually the data get presented to human being. So I have this very cute little baby here to present entire human race. I know some of you, it's far less cuter than this little baby, but that's fine, that's okay. They just say, this baby present the whole human being and, get the information from the monitor. Most likely, humans will take some action one way or the other to affect the things you actually monitor.
How critical is the human actually in the cycle? I mean, don't we want to get monitoring to the point where it only tells us the really important things?
Yes, that's the filtering, right? You probably just want to know what you want to know, right? You don't want to know everything else. So that probably is some kind of filtering, right, built in a monitor. You probably called alert or something, right? But normally this is the cycle, right? Human get the information from monitor, may take some action, somehow influence the subject that you monitor, then the cycle starts again, right?
Well, wouldn't the filtering be good because what's important to him might not be important, but might be important to me? So
Absolutely.
would be
Exactly.
Oh, we just thought that stuff.
either.
Yeah, totally.
Like,
Yeah.
the thing on my mind right now is what's Chinese from Manati.
What's the Chinese for money tea? Good question. I haven't really figured that out yet. You probably can help me. Right. So I think at a high level, that's pretty much a cycle. You can imagine how the monitoring work. So when we talk about monitoring, one of the very important things is the data, all the information that really describe or reflect the things you monitor. Right? So I define the data as a genuine reflection of things being monitored. You could have your own definition, but that doesn't really matter. This is some piece of information that you get by observe the subject, and you want to keep that information somewhere to be analyzed. Okay, so the data needs to be, as I said earlier, collected, persisted, analyzed. In many cases, need to be transformed, right? Eventually, one way or another, presented. You talk about this information you don't want to see. You just want to see some piece of important ones. That probably could be aggregation, right? Only when some threshold get reached, then you want to see it. So let's look at the characters. We look at the monitoring. So what is the monitoring as a service, right? So I define monitoring as a service is a service which provide monitoring. It's just like, you need somebody to fix something at your home, right? You call up this guy's number, and he come in, fix things, and then he leave. So the service is that, I need this service, I want to use it. After I finish, I'm done with it, okay? So I do not build that service myself. I use it, right? So this is what we're talking about here, monitoring as service. Let me check the time real quick. Okay, we have until 4. So the monitoring as service, first it needs to be open, right? I should be able to access it remotely, right? It's not just here in this room, right? I have to be physically available to access the system, and it has to be open. I'm talking about support those programmable APIs. So the other character is that, the data coming from the subject, monity, normally is a routine, right? They come in with some kind of intervals, right? It's not like the string, right? It could once a day, once a week, sometimes, once every second. But, there's an interval between those data coming in. So the system needs to be responsive, right? If someone wanted to see what is going on, then ask the system needs to be fairly responsive to provide the answer that the people want to see, right? Persistent. Data need to be saved somewhere. So later on, you can look at the data. Authentic. This is something I think when we collect data, we want the data describe the subject to be real. Truly describe the state or status of the subject you are monitoring, okay? Also, we wanted the data to be come into the monitoring system to be schema-free, because when you build a service, you cannot predict what data the subject may present to you, right? If you're monitoring, let's say, a microwave, the data most likely you get will be different when you are monitoring an airplane or car, okay? So the monitoring as a service has to be flexible enough to be able to take any kind of data, okay? So you cannot just strictly define, okay, this is a schema, that's the only type of data I can deal with, right? This is a very important requirement. Also, we're talking about design, software, system. We want to know the characters of the system we are, trying to build. For monitoring as service, it's very important to realize that you write a lot. You're constantly sending data to the system. You do very little update. There's no delete. When the data come in, it will stay. In very rare cases, you probably do an update, but many cases, it's just new data coming, right? And you don't delete. So those characters actually demand you design a system really meet its requirement, right? Also, we want the system to be elastic. If I monitor something really, really small, I can have the whole system in a very, very small machine, right? It does not require tremendous amount of resources. Or I'm monitoring, our cloud, thousands of a node, right? Now you have a system that is relatively big, right? So monitoring as a service needs to be elastic, right? Even a small system can have all the pieces, but it will still work, okay? As in you grow really, really big. And high availability. And of course, secure, because this service is on demand, okay? Right, so let's take a look at the data. what's the format of those data coming into your system? Modular case is the text-free. Here, schema-free. What I'm really talking about is just the JSON format. That can be any JSON. As long as it's a JSON format, we'll be able to handle that. And other format would be the video, audio. We're talking about flying drones. They take a lot of pictures. They sometimes make the movies, right? Those audio, video stuff. And there's some type of data, and of course, pictures. Some very common attributes for the data coming to a monitoring system. Unique identifier of the data itself, and a unique identifier of the subject you're monitoring. Those are really, really important. Without those, and it's very hard later on to correlate the data you collected. Okay. Of course, timestamp, right? When this happened, right? It's really important. And you can have all other things, latitude, right? Temperature, humidity. And those attributes do exist when you monitor anything. It's there. It's just many times people ignore them, do not provide this information. But you can if you want to. And this information down the road could be really, really important. And the other feature will be quantified measures of the subject. Let's say you are doing a microwave monitoring. Okay, very easy case. The quantified measure could be just, it's on, it's a 1, 1, 1, 1, right? You can have all that.
Now, when you're having all this data coming from all these different sources, are you collecting it for analysis later, or are you looking for analysis in real time?
That's a very good question. Actually, we will answer that when we go to the architecture part.
Okay.
Okay. So very quickly, the monitoring data value relative to time. This is something people sometimes forget. A study shows that the monitoring data value decrease when the data ages. Okay, so the most value you have are from the data you just collected, right? Of course, this line just shows the dropping of the value over the time. But let's say the data you have been preserved for a very, very long time. The value may increase. Just imagine you have some data describe the Earth, 20,000 years ago. That would be tremendous value, right? So, okay, how we actually do a collect, right? To collect data from the things we monitor. Normally there are two ways, right? There might be some other way, but I couldn't figure out. So I'll just say two ways. The common way will be, the things you monitor actually push the data to you. Say, hey, I'm good, I'm all right, everything's cool. So push the data out to the monitor. Monitor will pick the data and do whatever they want, right? There's some other things that doesn't do that, right? Will only give you data when you ask, right? As sort of like a pull module, right? So this is two common ways. There might be some other ways. For example, Monity probably accumulate a lot of data. Later on, do some kind of import. But I still think that's kind of similar to sort of push. But commonly, you have those push and pull method. On the right-hand side, I have this agent on the Monity. The reason why I did that is because you probably have a lot of existing devices or equipment. They probably don't do monitoring. They do not provide monitoring capability. Right? So how do you monitor those things? You can actually add on something, small component, which work specifically with that device, right? Get data, eventually either send the data, monitoring data to the monitor, or waiting for someone to ask for it. Okay, so I consider them like same proposition, basically. So that's a very kind of high level of collecting. But we know collect data sometimes can be extremely difficult, right? We mentioned the telescope, Hubble Space Telescope, right? We know how the data, get collected. You just take pictures, right? Send the pictures back to Earth and get analyzed. But since the telescope can up there and actually take those pictures, it's a tremendous task, right? So that's the collecting part. You can see the collecting part can be really, really difficult. So this is the architect for monitoring as a service. So at top, we have a monitor and its agent, right? Then we have a blue box is the presenter. Consider this like the web UI or some APIs, which allow you to see stuff, right? It could be a graph. It could be just simple text, anything you might want to support. This component will basically work with web server, right? Then we have the RESTful API server and the RESTful pooling servers to do pull and push, okay, from the stuff we trying to monitor. And the web server is not that very exciting. So let's look at the API server and the pooling server. So these two servers basically get data, collect data from the monitor, right? Then it will those two servers will put the data on a high performance queue. In our implementation, we use the Kafka queue, right? So this is a queue. It's quite different from many other queues used in OpenStack world. If you're really interested, want to talk about these things, we can talk offline. So we use this queue in the middle to support those pooling and RESTful API servers. Data pushed to the system will stay on the queue for a period of time. Okay. Then the queue actually will have the persister at the left-hand side, read data of the queue, and eventually save into a data store. And we are using Elasticsearch, and also for video, audio, images, we use the object store. Yeah.
So is the persister just a well-defined interface, and then you're plugging essentially drivers in for Elasticsearch and Swift, or does the persister have more than just sort of a driver plugin?
Yeah, it actually is. It's a layer that. Good question, by the way. It's a layer that allow you to use different stores, right? Let's say you really don't like Elasticsearch. You want to use some other stores, database, right? And that's the layer actually you will write your own driver that push data into not Elasticsearch but other stores, okay? We find that Elasticsearch is very well suited for this kind of system because, as I said earlier, the system has a lot of write, very little update, doesn't really have any delete. If you look at all other stores, this one is the one best fit this kind of criteria. Okay. Of course, Swift is an object store. You can use any kind of object store to save your video, audio, but you just need to have a very good way of associate those data with other data that you save in Elasticsearch. At the bottom, we have analyzer, we have transformer, we have aggregator. So those components read off the queue, right? This ensures that your data can be analyzed very, very quickly. Of course, we can design this to read data off the Elasticsearch, right? But that's another layer. When the data come in, placed on the queue, it's best for those components read off the queue, not to go back to the database or Elasticsearch. So this is for performance and for best of the response time, I should say that. And this component can also send the data out to other endpoints. Let's say you want to integrate this system with some other systems. So this is where you can add some component, read data off the queue, and send off. Okay. It's a very simple architecture. And this is the APIs we define. Extremely simple. If you want to push data to the system, and this is the API you can call. You just call post, then with all your data. If you want to implement the agent should support get HTTP. Very easy, simple. Okay, you can query the monitoring data, use those things. Okay, so actually with that, I introduce you the Manassa project, which is the implementation of monitoring as a service. This implementation actually is a joint effort by HP, Rackspace, and IBM. You can find the information by doing this. And also we have this IRC channel on Freenode. It's called OpenStack-Manassa. So let's say you actually want to put this into a real use case, right? You wanted to monitor something. So what do you need to do? Right? So find a service like this and start posting data. Let's say let me give you a real example. Let's say we in the OpenStack world, right? We have a lot of components. We have already wrote a lot of programs, right? We want to know what is going on with our system. So many of those programs already write the log file, right? So if you don't want to change your program, let's say in your program, you don't want to call those HTTP, issue those HTTP requests to send data over your login data to the system, you can write a little agent. Simply read your log files and throw over those log entries to the monitoring system. For any of your component, you can just use that little agent to throw your log files to the system. Then you can use all sort of APIs, graphing capability to know what your system is doing. So the only thing you have to do is write very little, probably take you a few hours to write that little program to read off your log file, send it over. Then monitoring as service system takes over, and you can have a full picture of how your system is doing. Right? This is where we're going. And right now, we will try to have an agent read off from the OpenStack queues, those rapid queue or QPID, whatever, because all the components in OpenStack already are posting the messages onto those queues, right? We just need read those messages off those queues and place into the system, okay? Let's say you're not doing cloud. You're developing, my favorite example, the microwave, right? Now probably you just need to make sure the microwave can get online, right? Have a little component there, send the data, say, hey, I'm good, I'm not broken. That's it, right? And you can have all the information available. Monitoring as a service, as you can see, we're not trying to solve all the problems in the world, right? We just want to emphasize collection of data and get the data into a system that you can do some simple, aggregation, like an average, min, max, so those sort of things. Now, as soon as you have all this data in, if you want to do some very complex analysis, you can easily hand the data from your Elasticsearch and simply copy the data and give to other big data systems, right? It'll be extremely easy. I think if we run out of time, we got 2 minutes. So that's my last slide. So we open for questions. Yeah.
What about alerts?
Yeah, actually, if you look at the, I probably shouldn't emphasize this. If you look at the architect chart, the alert will be something in this area, and then you can read off the queues and do whatever analysis you want to do, because the data is available to you, right? You can do filtering. You can add any alerting mechanism there, which can send email, can give you a text or call you, tweet you if you want to.
Yeah, but my question is, are you all thinking about adding extra work so that you can do alerts similar to Salometer and be able to send
Yes,
the things
yes,
to you?
yep, absolutely. Yep. Alert is one of the component actually Rackspace is developing right now. Yeah. Okay, any other questions? No? All right, great. Thank you.